Hey everyone, thank you for joining me today to solve this interesting problem. This problem deals with a plane flying with and against the wind, and we're going to try to find the speed of the plane in still air. All right, so let's get started. A plane can fly 500 miles against the wind in the same amount of time that it can fly 725 miles with the wind. If the wind speed is 45 miles an hour, find the speed of the plane in still air. To tackle this problem, the first thing you would want to do is to make a table. A table which will have the rate, which means the speed of the plane, the time it takes, and the distance it covers in that time. And also the two different cases we have, which is with the wind and against the wind. For the rate with the wind, we know that the wind is helping the plane to fly faster. So it's adding onto the plane speed. That'll be rate of the plane plus 45. Against the wind, it's slowing the plane down, so it's a negative 45 rate minus 45. The time it takes in both scenarios is the same time, so we'll just have t for time. The distance it covers for the same amount of time when the wind is helping the plane is 725 miles. And when the wind is opposing the plane only covers 500 miles. So where do we go next from here? We have rate, time, and distance. We can set up a relationship between rate, time, and distance. We know that distance equals to rate times time. We can do just that. We can multiply rate times time equals distance, which is r plus 45 times time equals 725. R plus 45 times time equals 725. We have our first equation. For the second case, we'll do the same thing, but we have r minus 45. R minus 45 times the time equals the distance covered was 500 miles, so 500. We're, our goal is to set these two equations equals to each other. We can see the t is common in both cases, so we will write both of this equation in terms of t. For the first case, t would equals to 725 divided by r plus 45. And for the second case, we'll have t equals 500 divided by r minus 45. We can see that t are the same, and also it states in the problem the same amount of time. So these two are equal, which means we will get 725 divided by r plus 45 equals 500 divided by r minus 45. Alright, now the goal is to find r, or solve this expression for r. What we can do is we can multiply 725 and r minus 45 and r plus 45 and 500, which would give us 725. We're just cross multiplying at this point. R minus 45 equals 500 r plus 45. So right now we can start distributing the 725 over r and 45, and we can distribute 500 over r and 45. But these are big values, so the thing you want to look out for is to simplify them before we start distributing. We can see that 725 and 500, they can both be divided by 25. 25 times 29 is 725, so we are dividing 725 by 25, which gives us 29. Dividing 500 by 25 will give us 20. We're just dividing both cases by 25. So, okay. So now we have a much simpler equation to solve. So 29, oops, okay, r minus 45 equals 20 r plus 45. Distributing that over, we would get, distributing 29 over this r and 45, we'll get 29 r minus 1305 equals, missed the zero over there, it's 20 times r plus 45. Okay, and over here we'll have 20 times r, which is 20r, plus 20 times 45 gives us 900. Okay, at this point now we'll try to move this 20r on this side so we can subtract the 20r from the 29r, and we'll add 1305 on both sides to move this 1305 on the other side. So 29r minus 20r plus 1305. We'll do the same thing on this side, minus 20r plus 1305. We can see that 20r minus 20r goes away. 1305 plus 1305, that goes away. We'll just have 9r equals 2205. Now if we divide 9 on both sides, we'll find our rate of the plane in still air. We get 2205 divided by 9 gives us 245. So the rate of the plane in still air is 245 miles per hour. And that will be our final answer. Thank you.